Assalamualaikum warahmatullahi wabarakatuh. My name is Ammar Faeid, bin Fadzil, with symmetry number 2317263. And today, our group will present our project, which is IIUM Lost and Found System. The purpose of this project is to centralize the reports and recovery process for the lost items. The system aims to reduce manual reporting currently used, such as Telegram group, where the posts are easily overlooked. We also plan to minimize the number of unclaimed items left in campus facilities by streamlining the recovery process. For our scope, we have divided into three, where the core functionalities by the systems includes user authentication via a IIUM credential, item reporting, a searchable database with filter, and automatic message notification. And then we have a administrative control, where it provides the students a fair department or stat and security office with an admin dashboard to verify ownership claims and manage the database to ensure authenticity. Finally, by the system boundaries, platform acts as a digital notice board and tracking tools. For our stakeholders, firstly is IUM community, where they will report the lost personal belongings, upload details of items they found and search lost items. And then we have a stat where they are managing the database, verifying the ownership claims for lost item and handling the unclaimed property. And then we have the information technology division, which is ITD, where they're maintaining the server and ensures the secure login. And finally, we have the IUM administration, where they are reducing the manual paperwork, minimizing the number of unclaimed items in campus facilities, and improving overall student welfare. Now we go to the functional requirement. Uh, the first one is the report lost item. The system shall allow users to submit a lost item report with details, date, and location. Second is the report found item. The system shall allow users to upload details and photo of found items. And then we got automated matching. The system shall notify the user when a found item match a submitted loss report. And then we got the claim initiation, where the system shall allow users to initiate a claim for a found item. Finally, we have admin verification, where the system shall require admin verification of ownership before marking an item as returned. For the quality requirement, the first one is usability. The system shall allow users to submit a lost item report with details, date, and location. Secondly is security. The system shall allow users to upload details and photo of found items. The third one is for the performance. The system shall notify the user when a found item match a submitted loss report. Number four is the integrity, where the system shall allow user to initiate a claim for a found item. Finally, reliability. The system shall require admin verification of ownership before marking an item as returned. Now for the use case diagram, you can see the clear separation of roles. The user, which is the user and staff, handle the front end action like searching and reporting. Notice the include relationship between claimed item and verified items. This highlight that a user cannot successfully recover an item without the mandatory verification step from the stat or the security office. Moving on to our flowchart. This represents the high-level operational logic of application. First, the process begins with the secure user login, followed by a decision point where the user chooses to report a lost or found item. Then, depending on the choice, the user enters a specific details and photos, which are then saved to the database. Once saved, the flow moves into the administrative phase, where admin managed report is triggered. Finally, the system facilitates a match. The user initiates the claim, and the process concludes only after the admin verifies the claim, ensuring the item is returned to its rightful owner. Next, we go to the activity diagram. We divide it into three, which is user, system, and admin. The user is responsible for the initial data entry and form submission. Now into the system lane. If the data is incomplete, the system will create a loop that forces the user to correct the entry before the proceeding. Once the system validates the entry, it moves to the admin lane for the mandatory review and publication. And for the final step is automated. The system broadcasts a notification to users closing the cycle only after human verification has occurred.
Assalamualaikum warahmatullah. My name is Ghafur. I'll talk about architectural pattern and styles and also why we chose it, okay, for our system. So the chosen pattern is layer client server architecture. So what does it do? It organizes the system into layers with distinct responsibilities and control communication between adjacent layers. So why we chose this? The answer is simple. It has clear separation of concerns and modularity. It is secure, role-based access control, and lastly, it's secure, scalable, maintainable, and easily extendable for future features. So, like I said before, this is for IIUM last and found system. It will cover only whole on the whole IIUM. You want to actually expand it outside of IIUM, for example. Okay. Let's now talk about the layers inside the layer client server architecture. Okay, there's four. The first one is presentation layer. It handles user interaction. For example, allows reporting, allows searching, and also claiming items. Next, we have application layer. This functions as to execute core functions. That, for example, process item matches. There is also ownership claims and status tracking. Next, we have service layer, the third layer that is to provide usable services. For example, to manage authentication and authorization, of course, to send notification and item management as well. And the last layer is going to be data layer. That is to manage data storage and retrieval. Okay, so it maintains user account, lost and found item records, claim logs, and also audit trails or audit logs. Okay. Let's take a look at our component design. Here is our system architecture. Like I said before, the first layer is going to be a presentation layer, the mobile and web interface. Okay, so here we can see the user view. There is going to be a login page, login UI. There is also the whole dashboard for admins. There is also going to be a list of items that has been found, or maybe a request to find this item. Okay, there's also search and filter. That's for presentation layer. That's absolute view for users and the admins. Next, we have application layer. That is to function the core features. Okay, there's going to be item management, claim processing, matching engine, admin verification. Okay, for the next layer we have service layer. This is to authenticate. This is to find item. Next we have to manage notification, and lastly it can also authorization. Okay, and for the last data layer, it's going to be our database. It will store every single information that we want in the system. Like for example, the system want to store user account, AUM credential. Next, we have the lost and found reports and audit logs to track what's gone, uh, what has been reported, something like that. Okay, that's for the component design. Let's talk about tactics for non-functional and quality requirements. So the first thing first on usability, that is intuitive interface. The interface should be consistent. Next, we have guided workflows. There's going to be a guide after the user login for the first time. And next, we have responsive design. Of course, this is web apps, so user can access the webs using their phone, using their tablets, using their laptops, all have different views, all have different perspective. We want to make sure everything is good on them. Next, we have performance and data caching for general process. We catch so that the the system won't take a lot of memory. Next, we have asynchronous processing. We want to like notification. We send it right after what happened. Oh, you found this item. Then it will notify the user that lost the item. Next, we have load balancing for more than 100 users. IAUM has lots of students. We want to make sure this available for all of them. So yeah, of course, we make sure that to be able to the system will be able to run almost over these 100 users. Okay, next we have security. We use official IAM credential, role-based access for users and admins, HTTPS for more secure gateway, and next we have audit logs as well, so it can keep tracks of what's going on. Okay, the reports basically. Next we have reliability. It has centralized database, can have backups as well. Also, there's error handling, and lastly, transactional management for the cache gone. Next, we have maintainability, we have layer design, modular service, and documentation. And lastly, for the accessibility, like I said before, responsive design, this is for mainly for impairment site impairment. Okay, proper text or visual contrast, and lastly, keyboard navigation. That's all for tactics for non-functional quality requirements. Thank you.
Okay, my name is Mohd Zakwan bin Mohd Shukri, and I will explain about detailed design. Okay, for the first design pattern we choose is factory design pattern. It is because the factory design pattern is creational design pattern. It creates object without specifying exact class and provides centralized object creation logic. So in the class diagram, it shows four class, which is the factory, the item factory. The purpose of this is to create the object, and we have the abstract class, which is item, to define the interface. And we also have the concrete class, which is lost item and found items. The purpose is to create the items. And we can also see the relationship, which is the item factory create lost item, items, and found item. It indicates the dependency relationship, and for the lost item and found item, it indicates the inheritance relationship between the concrete item and the abstract items. So we go to the next slide. So this is the example code. We have the code for our item factory, and then we have the concrete class, which is our lost item and found items. We also have this abstract class code. As you can see, the abstract class is used with factory patterns, and the item factory is encapsulate object creation logic. It hide the complexity of creating lost item and found item object, and only clients only needs to call the create items without knowing the subclass details. So we go to the next design pattern, which is the singleton design patterns. So in singleton design pattern, it is also a creational design patterns, and we do this because we want to ensure only one instance of the class exists, and also provide the global access point to that instance. So in this class diagram, you can see that we have the singleton class, which is the database manager, and if every part of the code want to access, you need to just use the get instance to have to get the access in the database manager. So this is the code for our database manager. We have this to ensure only one instance of database exists throughout the application, and we also have the private constructor to prevent instantiation. static get instance control access, and static final instance create at class loading times uh, for the eager initialization. Also, the private constructor to prevent direct instantiation, and we use get instance to return the single instance. This is to ensure only one database manager exists. The next is detail the observer design pattern. This we choose this because the observer design pattern is behavior design pattern. It also have one-to-many dependency between objects, and when object change, all the dependent are notified. So this is the class diagram for our observer design pattern. We have the observer, which is the interface type. It will define the update to the user. We also have the item matcher, which is the concrete class. The purpose is to manage and notify the user. And lastly is the user, which is the concrete class. The user will receive the notification from the item matcher. So this is the example code. You can see the observer interface define contract for observe to receive notifications, and this is the user class, which is the concrete observer. Concrete implementation for user to receive notification for item match, and this is the item matcher. It acts as an subject or publisher in the observer pattern to maintain list of observer and notify them for an event. So I think that's all from me. Thank you.